Welcome students. Elastic constants. Elastic constants expresses the relationship between stress and strain in the elastic region. So Young's modulus, bulk modulus and rigidity modulus. These three are the elastic constants. Young's modulus, bulk modulus and rigidity modulus. This Young's modulus is the ratio between the normal stress and normal strain. The bulk modulus is the ratio of normal stress and volumetric strain. You can see normal stress are compressive stress divided by volumetric strain. Rigidity modulus, it is a ratio of shear stress and shear strain. Now we have to derive the relationship between the different elastic constants. First is the relationship between Young's modulus and bulk modulus. That is E is equal to 3k 1 minus 2 mu, where mu is the Poisson's ratio. Next is the relationship between E and G. E is equal to 2g 1 plus mu. The third relation is the relationship between Young's modulus, bulk modulus and rigidity modulus. E is equal to 9 kg divided by 3k plus g. So first we shall derive the relationship between Young's modulus and bulk modulus. We know that the generalized Hooke's law, that is the strain in x direction is equal to stress in x direction divided by E minus Poisson's ratio, strain in y direction stress in y direction divided by Young's modulus minus Poisson's ratio into stress in z direction divided by E. Similarly, you can have the equations for strain in y direction and strain in z direction. Using this generalized Hooke's law, we can derive the volumetric strain. The volumetric strain epsilon v is equal to 1 minus 2 mu into sigma x plus sigma y plus sigma z divided by E. Consider a cube subjected to stresses in the mutually perpendicular directions as shown in the figure. Here sigma x, sigma y, sigma z all are equal to the same value sigma. So instead of the sigma x I can write a sigma, and sigma y I can write sigma, and instead of sigma z I can write as sigma. So I will be having 1 minus 2 mu into 3 sigma by E. So volumetric strain epsilon v is equal to 1 minus 2 mu into 3 sigma by E. Keep this as equation 1.1. Also we know that bulk modulus, it is a ratio of stress by volumetric strain. So you write this volumetric strain on the left hand side. So I'll be getting volumetric strain is equal to stress by bulk modulus. Now you substitute this volumetric strain is equal to sigma by k in equation 1.1. So if you substitute here, you will be getting sigma by k is equal to 1 minus 2 mu into 3 sigma by E. So sigma gets cancelled, and you will be having E is equal to 1 minus 2 mu into 3k. So this is the relationship between E and k. Now we have to find the relationship between Young's modulus and rigidity modulus. You take a cube. This is one face of the cube with the corner points A, B, C, D. The side AB is fixed. AC and BD are the diagonals. So if a shear stress is acting on this body, what happens is this body gets deformed. This BD is the initial diagonal, and this BD1 is the diagonal after the deformation. So this is before the deformation, and this right hand side diagram is the diagram after the deformation. So you can see that the diagonal BD has elongated from this position to this position. So the length of the diagonal changes from BD to BD1. Now we have to calculate what is the strain in the diagonal BD. So strain in the strain in the diagonal BD, strain in diagonal BD is change in length by original length. So this is the change in length of the diagonal BD. So initial length was BD and the final length was BD1. So the change in length of the diagonal BD is BD1 minus BD. So I have to substitute this delta L BD here. So BD1 minus BD divided by BD. BD1 by BD. So this you have to refer in the diagram. BD1. So the total this length from here to here. So this is your BD1. In this length I have to subtract a BD. You draw a line from D to M. That is from this point you draw a line D to M. Sorry, you don't know the point M, that you have to find. From D you draw a line. That line has to be perpendicular to the line BD1. So the condition is you have to draw a line DM such that this DM is perpendicular to BD1. Also, you will find that the length BD will be approximately equal to BM. So with this we shall come to this point. So BD1 minus BD. So BD1 minus BD. From the figure, the total length of the diagonal is BD1 after deformation. From this you have to subtract BD. We know that BD is equal to BM. BD is equal to BM. So if you subtract BD from BD1, you are subtracting BD. BD is equal to BM. So you are subtracting this part from BD1. So the remaining part will be this part, that is D1M. So BD1 minus BD is equal to D1M divided by BD. Up to this we have seen. Now we have to find an equation for D1M. So D1M. So you take the triangle D1M. The triangle MDD1. So in this triangle cos 45 degree. Cos 45 degree. So this is your angle 45 degree. The adjacent side is MD1 and the hypotenuse is DD1. So cos 45 degree is equal to MD1 divided by DD1. Cos 45 is equal to 1 by root 2. So from this equation you find what is D1M. D1M or MD1. D1M is equal to DD1 by into cos 45 or DD1 by root 2. So now we have to substitute this D1M value in equation 1.3. In equation 1.3, I am substituting the D1M value. So after substitution, I will be getting DD1 by root 2 into BD. So this is your equation 1.3. Next in triangle ADD1. So this side triangle ADD1. In this triangle, you take what is the angle of tan pi. So tan pi is equal to opposite by adjacent. The opposite is DD1. So this is your opposite and this is your adjacent, DD1 by AD. This angle, if pi is very small, then tan pi is equal to pi. Like that I can say. So pi is equal to dd1 by AD. Take this equation as 1.4. Now in triangle ABD, ABD. So this right angle triangle, sine 45 is equal to opposite by adjacent. Opposite by hypotenuse. So this is your opposite side, AD. So this is your opposite, and this is your hypotenuse. So sine 45 is equal to 1 by root 2. From this you find what is AD. AD is equal to BD by root 2. This you keep it as equation 1.5. So three equations we have arrived: 1.3, 1.4 and 1.5. Now substitute this AD value in the equation 1.4. So I will be getting equation 1.4 as pi is equal to dd1 divided by bd into root 2. So pi by root 2 is equal to dd1 by bd. This you keep it as equation 1.6. So I have got equation 1.6, that is pi by root 2 is equal to dd1 by bd. So this is equation 1.6. Now I have to substitute this value in equation 1.3. So where I have to substitute? See, I am having a term by dd1 by bd. Instead of this dd1 by bd, I have to substitute this pi by root 2. So your equation 1.3 will become strain in bd is equal to dd1 by root 2 into bd. Instead of this value, I have to substitute pi by root 2. So root 2 into root 2, it becomes 2. So finally I'll be getting strain in BD is equal to pi by root 2. So this is your equation 1.7. We know that shear stress by shear strain is equal to rigidity modulus. From this you find what is shear strain. So shear strain is equal to, so this is shear strain. Shear strain is equal to shear stress by rigidity modulus. So I have to substitute the pi value. Pi value is equal to tau by g. This pi value I have to substitute here. So I will be getting the equation 1.7 as strain in BD is equal to tau by g into 1 by 2. This is equation 1.8. See, after deformation, your figure will look like this. This BD1. The strain, the total strain on BD is equal to the strain on BD due to the tensile stress on BD plus strain on BD due to the compressive stress on AC. See, due to the shear stress, what happens is on BD, tensile stress acts, and on AC, compressive stress acts. Due to the tensile stress on BD, you will be having some strain, and due to compressive stress on AC, you will be having a strain on BD. So to find the total strain, you have to add these two strain terms. That is, strain of BD, total strain of BD is equal to strain on BD due to the tensile stress on BD plus strain on BD due to the compressive stress on AC. So if you have a body like this, the strain in the direction of force is given by force stress by the modulus of elasticity. So here shear stress acts. So I can write the strain on BD due to tensile stress as shear stress by Young's modulus. And this strain on BD due to the compressive stress on AC. So this strain is at right angles to this strain. So you have to bring the term Poisson's ratio. Tau divided by E into mu. This mu is taken into account for the deformation that happens in right angles to this direction. So strain on BD is equal to tau by E into 1 plus mu. This you keep it as equation 1.9. Now I have to substitute the equation 1.8 in equation 1.9. So what is equation 1.8? Equation 1.8 is the strain in BD is equal to tau by 2g. The strain in BD is equal to tau by 2g. So this is your equation 1.8. So I have to substitute this value instead of this strain, total strain on BD. I will be having tau by 2g is equal to tau by E into 1 plus mu. So tau gets cancelled. Finally, I will be having E is equal to 2g 1 plus mu. This is the relationship between Young's modulus and rigidity modulus. Now we have to find the relationship between Young's modulus, bulk modulus, and rigidity modulus. We have got two equations. One is the relationship between Young's modulus and bulk modulus. The second is the relationship between Young's modulus and rigidity modulus. So you have two equations A and B. From the equation A, you find out what is Poisson's ratio. So this is how the steps are proceeded. So first take 2 mu on left hand side and the remaining on the right hand side. Then you divide both sides by 2. You will be getting Poisson's ratio mu is equal to 1 by 2 minus E by 6k. And then you take equation B. In equation B, you take mu Poisson's ratio on one side and the remaining on the other side. Therefore, you are having two equations. Both are Poisson's ratio. Equations of Poisson's ratio. So both are same. So you equate both these equations. The right hand side of both the equations. So 1 by 2 minus E by 6k. So this is this term and this is this term. So if you solve this, you will be getting 3 by 2 is equal to E by 2g plus E by 6k. E is common in the numerator, so take E outside. Similarly, 2 is common in the denominator, so you take 2 outside. So you will be having an equation like this. Cancel 2 on both the sides. I will be having E is equal to, 3 is equal to E into 1 by g plus 1 by 3k. You cross multiply this, finally you will be getting 9gk divided by 3k plus g is equal to E.